Global industries rely on standards development organizations like ISO and NIST to maintain the protocols that keep complex supply chains connected and compliant. Yet the rules governing this vast web of data exchange share a critical flaw. They exist almost entirely as static text-based documents. Because these standards are published as manuals, enterprise software teams are forced to interpret the rules and hard-code them into isolated systems from scratch. This creates systemic fragmentation. When thousands of isolated databases try to align with a single document, the resulting mismatched data formats require expensive post-hoc auditing just to verify basic compliance. Static documentation cannot actively enforce real-time interoperability within a living digital economy. Modern enterprises require automated, executable infrastructure. Maintaining disconnected data silos drains vast amounts of capital and operational bandwidth. Every time a part changes hands or a financial instrument clears, human administrators or patched-together APIs must manually verify that the action meets the documented standard. Saga Standards addresses this by embedding the rules directly into the digital assets themselves. Specifically, Saga Standards does not function as a standards development organization. It does not author new industry standards to compete with the consensus work of established bodies. Instead, it acts purely as an operationalization layer. It takes existing industry text and transforms those rules into structural digital blueprints. These digital structures are designed to be universally reusable across disparate global industries. For these structures to function universally, they must be anchored in a persistent system state. Saga Standards provides the missing structural bridge, converting static text into executable governance. Executing global standards autonomously requires a foundation built specifically for that task. That bedrock is Saga Chain, a persistent state data management environment. Persistent state means the data and its operating logic live together permanently on the chain, preventing the fragmentation caused by passing data copies between databases. Within this environment, complex physical and legal entities are managed as structured digital objects. These objects can represent financial instruments, specific aircraft components, or overarching governance structures. They can also precisely trace individual batches of pharmaceuticals, regulatory artifacts, and rights-managed digital media assets. The grid of this persistent state environment serves as the absolute base layer of the entire architecture. By residing on this layer, a real-world entity becomes a structurally persistent object, maintaining a single, unbroken record of its own history and properties. The properties and behaviors of these objects are defined using Saga Python, the native programming language of the ecosystem. Without the bedrock of persistent state, true object-oriented standardization remains impossible. Moving one step up the stack, we reach the logic and operationalization layer. Here, the guidelines provided by external standards organizations are translated directly into native Saga Python code. This code is organized into canonical class trees within the Saga Standards framework. This hierarchical class tree maps the rules of a static document into a functioning logic structure. These green class trees serve as reusable blueprints for any system interacting with the chain. Compliance shifts from human interpretation to infallible structural system logic. A class tree is only a blueprint. It must be applied to functional digital objects to operate in the real world. This brings us to programmable smart assets, or Saga PSAs, which act as the instantiated representations of physical entities. Through the mechanic of inheritance, these assets natively absorb their properties and behaviors directly from the standard-aligned class definitions. As the asset connects, logic flows downward, permanently binding it to standard rules. The Saga PSA self-validates internally, eliminating external queries or manual audits. Amending the parent class tree instantly propagates standard updates to every connected asset globally. The asset itself becomes the autonomous enforcer of its own operational compliance. For the end user, this results in absolute frictionlessness when connecting external enterprise software. The enterprise application layer interfaces cleanly with the fully built stack. Because the rules are embedded directly in the asset, compliance conditions and provenance are evaluated programmatically during live system execution. This shared canonical structure eliminates the reconciliation errors that consistently break siloed global systems. Operationalizing global standards into a single infrastructural layer naturally raises questions about centralization and control. To ensure neutral governance, this architecture is overseen by the Prasaga Foundation. The foundation acts as an overarching legal and structural shield for the network. It operates under a defensive patent policy designed to protect the openness of the Saga standards infrastructure. These patents exist solely to prevent hostile enclosure, legally guaranteeing that the foundational operational layer remains cost-free and openly accessible. By solving the problem of static data translation, organizations can move permanently to true executable governance. The macroeconomic impact of programmatic standardization scales exponentially when applied to global networks operating with flawless precision. Reducing fraud and accelerating compliance yields trillions of dollars in potential efficiency gains across aerospace, healthcare, and global supply chains. Globally recognized standards now function as live, interoperable tools. Saga Standards provides the operational engine required to run the decentralized digital economy.